Okay guys, this is the first of 3 parts I'm going to do today, and then there's going to be at least a part 4 later on this afternoon, this evening. Okay, anyways, let's get started here. So, IM3 Unit 4 review. I've done this in several videos now. The first thing we have to remember to do is make sure everything is factored. This is a times problem. So we don't want to just factor the denominators, we want to factor everything we can. So notice this right here, I can do a GCF of 5, right? So if I do a GCF of 5, I know that's R plus 8. So that's done. The denominator stays R plus 8. We have a times. A 1, of course, stays a 1. This right here, I can factor using the X method that a lot of you guys like to do. So I need a negative 20 with an 8. That would be 10 minus 2, 8. 10 times negative 2 is negative 20. Excellent. So we have a R plus 10 and an R minus 2. Now that everything is factored, again, this is a times problem. We're just going to take something in the numerator, match it up with something in the denominator, cancel or simplify, as we say. So notice R plus 8 cancels out with R plus 8. And if you look carefully, guys, there's nothing else I can simplify. So I'm just going to time straight across here. 5 times 1 is a 5. And in the denominator, all I have is R plus 10 times R minus 2. Normally there's a little bit more. Usually you could simplify or cancel out, but that's all there was to that one. Okay, now this is a divide. We're going to do the same thing as times, except we're going to do a reciprocal on the second fraction. So the 1, of course, we can't factor. 7v, we can't factor. We have a divide, so we're going to make that in the times. Multiply, right? And the v minus 8 can't be factored, but now it's in the denominator. And this, once we factor it, it's going to go in the numerator. Let's do an X on it. So we need a 40 with a negative 13. So how about negative 8 plus negative 5 is negative 13. And negative 8 times negative 5 is positive 40. So we have a V minus 8 and a V minus 5. All right, everything is factored. We did our reciprocal over here already. It's now a times. So now I'm just going to simplify. V minus 8 cancels out V minus 8. And guys, guess what? That's it. I have a 1 times V minus 5. So V minus 5 over, the only thing left in the denominator is 7V. That's it, guys. Don't get weird and try to simplify V with V, because this V has a minus 5 locked with it. You see? So that's why you don't want to do anything weird like that. Okay, that's as simple as you can get it right there, guys. Okay, now guys, this one, basically we're going to make sure our denominators are factored, and we're going to times everything by the common denominator. So if we look at our denominators, that can't be factored really, neither can that, neither can that. But does everyone agree all of them had an x squared in common? This one, however, has an extra 3 factor with it. So the common denominator, guys, I hope you understand, is a 3x squared. And hopefully you notice how I set it up. So now I'm ready to simplify. I know that x squared over x squared is 1. All I have is 3 times 1, which is 3 left over, equal, in my middle expression here, notice the 3 and the x squareds cancel out. So all I'm left with is that x plus 1 plus, on the right over here, I'll circle it in green, the x squareds cancel out. I'm left with 3 times 4, which is 12. Now all I have to do is solve, right? I have 3 equal to x plus 13. Once I minus 13 both sides, x is going to equal negative 10. 3 minus 13 is negative 10, right? Now, you normally want to check your answer, guys, but let me just tell you that if you plug in negative 10 there, and there, and there, it will work. And in a previous video, I showed you how you can use a calculator to verify that, okay? The key thing that's obvious, though, is do you agree negative 10, when I plug it in, I'm not dividing by 0. That is the most obvious error that you can make. And that's how we usually get extraneous values. So I would say this one does not have any extraneous values. Negative 10 should work. Okay? Let's do one more. So first we got to find our common denominator. Notice this first fraction has an a plus 2 in it. The second fraction or expression has an a plus 2 in it. This one technically has a 1 as a denominator, right? So what is our common denominator, guys? Is a plus 2. See how I'm going to times every part by a plus 2. Now watch what happens. A plus 2 cancels out a plus 2. I'm left with a minus 4 equals. A plus 2 cancels out with a plus 2. I'm left with a squared plus 6a plus 5. Minus, watch those signs. Over here is actually the sucky part because the 1 does not simplify with a plus 2, really. So I actually have to times those together. So I'm going to use the box method to do that. So I'm going to take a plus 2 times with a plus 1. A times a is a squared. A times 1 is 1a. A times 2 is 2a. 1 times 2 is 2. So I hope you agree I'm left with a squared. 1a and 2a is 3a plus a 2. All right, let's put it with the rest of the problem. A squared plus 3a plus 2. Just verifying, guys. Now, there's this minus we have to distribute here. So let's take one extra step here. We have a minus 4 equal to a squared plus 6a plus 5. I'm just showing my work here, guys. Minus a squared minus 3a minus 2. Okay, a minus 4 equals a squared minus a squared means no a squared. Awesome. 6a minus 3a is 3a. 5 minus 2 is a 3. Solving, I'm going to minus a, guys, both sides. And I'm going to get negative 4 equal to 3 minus 1 is 2a plus 3. I'm now going to minus 3 both sides. So 2a is going to equal negative 7. And once I divide both sides by 2, I know a is going to be negative 7 halves. And I noticed that if I plug that in there and there, I'm not going to be dividing by 0. So I'm going to trust that I didn't make any silly mistakes, guys. The answer should be negative 7 halves. Now, in my previous videos that I made on this, I actually showed you how I would plug it in with my calculator using parentheses and stuff correctly to make sure it did work. To save time, I'm not going to do it here, but I'm going to assume I didn't make any silly mistakes. Most of my work, if not all of it, is correct, however. And hopefully you've learned something from it. But guys, that's how you solve these rational equations. Let me verify. Yeah, there's nothing else left on this video. I will have, again, 2 more videos following this one for now. And then, of course, There'll be at least one more video later this afternoon, early evening sometime, okay? See you around.